So yesterday, oh, should we wait on Caitlin? Or
I think she probably forgot about that.
okay. So yesterday we worked a little bit with finding the greatest common factor of two different fractions, or two different numbers, by using a factor tree. And then we used the greatest common factor that we found in order to find an equivalent fraction. So can anyone, who remembers what a greatest common factor is, or who can tell me a good definition? Yeah.
The greatest common factor is
Yep.
It's like a number that goes into both numbers, but it's like the highest.
Okay. So greatest common factor, or GCF, is, can you say that one more time for me? That was a great definition. I think you said it was a number.
A number that goes into both numbers, that's the highest.
So that two numbers have in common, and it's the highest. In common. That's the highest. Hi, Caitlin. So we used the greatest common factor that we found.
Right.
You're fine. In order to find equivalent fractions. So does anyone, off the top of their head, can anyone give me an example of an equivalent fraction?
2 and 4.
What?
2 and 4.
2 and 4? Is that a
No,
fraction?
2/4.
2/4 would be equivalent to what?
1/2.
And how can we prove, because Sheem told us that 2/4 is equal to 1/2, so how can we prove that this is true? Can someone raise their hand and tell me? Caitlin? Divide what by 2? Both numbers? So this one, you're saying? Divide this one by 2? Okay. So the numerator up here, the top number, the numerator, divide that by 2. So 2 divided by 2 is 1, right? And then do I divide the denominator as well? Okay. So 4 divided by 2 is also 2. So, Aaron, can you tell me how we know to divide by 2?
Because they both share the same number. Like they both have like 2 times 2 is 4. I'm not so sure about the top.
What vocabulary word can you use that we've been working on to know that you're doing what you're supposed to do? What do you find?
UCF,
Okay.
the greatest common factor.
Yep.
Greatest common factor.
Good. So the greatest common factor of these two numbers would be
1. 2.
Yep, 2, because it's what you're dividing by. So that's the greatest common factor for 4 and 2. So yesterday, like I said earlier, we used factor trees to help us out finding the greatest common factor. So if I have the numbers 8 and 32, can you guys walk me through making a factor tree for these two numbers? So what two numbers multiplied together is 8? 4 and 2? Are either of these prime? 2 is? Okay, so I'm going to circle 2. How about 4? You can go to 2 and 2.
And those are from.
And both of those are prime? Alright, how about for 32? This one's a little bigger number.
8 and 4.
8 and 4? Are either of those prime, Kat? No? How can we go a step further?
4 and 2.
4 and 2 for 8?
No.
So 4 times 2.
And 2 and 2. For 4.
For both 4s? So there. And then also here. Okay. So using this factor tree, how can we find the greatest common factor? Raise your hand, please. Kak?
You would both numbers are in common.
So what do you mean by that?
Like 8 and 32 both have 2 in common.
Yeah, I 2's over here, and I have 5 2's over here. So what do I know from that? So we have the 2's, you're right. But how many 2's do I have in common between these numbers? So I have 3 2's. So knowing that I have 3 2's that are in common, so 1 2, 2 2, 3 2's. Because that uses up all of the 2's in the 8. So it has no more, doesn't have any more numbers that are in common. So what can we do with those numbers to then find the greatest common factor?
But if you look into the greatest common factor, you can look for
Is it 4? Well, I think yesterday we said we had 3 2's in common. And I think yesterday when we had, multiplied them together. So multiplying them together helps us find the greatest common factor. So if that helps us find the greatest common factor, how can we use our knowledge of these numbers to find the greatest combination?
2 times 2
2 times 2?
equals 4.
Okay, so we know 2 times 2 equals 4. But I have one more 2 that's in common.
'Cause you're right, 4 is a factor,
Yeah.
but we haven't found the greatest common factor yet.
Caitlin?
2 times 3 equals 6.
Where do you see the big
Where's the 3? I have 3 2's, you're right. Cac?
You multiply 3 2 together.
Yeah. So are you telling me to do 2 times 2 times 2? What does that equal? 8. So our greatest common factor is then going to be 8. Does everyone see how we did that? We knew that we had 3 2's that were in common. So I took 1 2 times another 2 times another 2 to get 8, which is our GCF. How about, so our greatest common factor is 8. And so if I have the fraction 8 over 32,
1/4.
okay, can you tell me what you did to find an equivalent fraction to 8 over 32?
Divided 8 by top and bottom.
Okay, how did you know to divide by 8?
Because we already knew 8 was the greatest common factor.
Can you say that again? I didn't.
I already knew 8 was the greatest common factor.
8 was the greatest common factor. So Hashim says he knew that 8 was the greatest common factor, so he could divide the top and bottom to find an equivalent fraction. And you said what was the equivalent fraction? 1/4. So 1/4 is equivalent to 8 32nds. Today we're going to be working on plotting or putting these numbers on a number line and then using the number lines to compare two different fractions. So I have 2 number lines up here. One of them is split into 4 pieces and the other is split into 2 pieces. And I want to put 1/4 on one of these number lines. So I'm going to choose to do the top one because it's split into fourths, and that's easy for me to see that I have 1 out of 4 pieces that I'm putting on the number line. So 1 out of 4 pieces would be here. What if I wanted to
Can I
plot?
interrupt you real quick?
Yes.
This is the part when you guys did that pre-task that people didn't do very well on. When you were given a fraction and asked to put it on a number line or identify it. So make sure that you're really paying attention because this is a little piece of the puzzle that I think a lot of you are missing.
So I chose to use this number line because down here it tells me I have one piece out of 4 pieces. So I have 1/4 of something. And over here I have a number line that has 4 pieces, so 1, 2, 3, 4. And down here I have a number line that has 2 pieces, so 1, 2. And if I have 1 out of 4 pieces, the dot, I'm going to put the dot right here. So now we're going to look at another set of numbers. So let's do, can you guys help me do a factor tree for 9 and 18? So for 9, how can I start a factor tree? Someone raise their hand and tell me. Hashim? 3 and 3? Are those prime numbers, or do I need to keep going?
Yeah.
They're prime numbers? Alright, how about for 18? This table over here. Bryce?
Well, like, you could do like 9 and 2,
Uh-huh.
or you could do 6 and 3.
Yeah, so let's go with 9 and 2. Are either of these prime? Boys, Aaron, are either of these numbers prime here? The 2? Alright, what's our next step? Cac? 3 and 3. Are those prime? Alright, so how can we find our greatest common factor using our factor tree?